Okay, guys, today we're going to be taking a look at triangles and some different properties. To begin with, let's talk about what a triangle is. Hopefully we know that, but a triangle is a three-sided polygon, so it has three sides. If we are trying to classify triangles, there's two ways that we can do that. We can classify triangles by their sides and by their angles. The first way I want to talk about is classifying by their sides. If we're classifying by sides, we have three options. We could say that a triangle is equilateral, which happens when all of the sides are congruent. We could say that a triangle is isosceles when two of the sides are congruent. Or we could say that a triangle is scalene when none of the sides are congruent. Okay, so if there are no sides that have equal measure, then that's scalene. Two sides equal, that's isosceles, and then all three the same are equilateral. The other way, as I mentioned, is classifying by angles. Okay, so it has to do with what types of angles are inside of the triangle. The first example is an acute triangle. Now, the example there that is drawn happens to have all the angles equal. That's called equiangular. That doesn't have to happen in order for the triangle to be acute. If all three angles are acute angles, then the triangle is acute, no matter what their measures are. As long as all three angles are acute, then the triangle is an acute triangle. Take a look at the second one. We can call a triangle obtuse if one of the angles is obtuse. Okay. In the example given, there's an obtuse angle of 124 degrees and the other two are acute. This is how an obtuse triangle will look. You'll have one obtuse angle and then the other two will be acute angles. A right triangle has one right angle and then the other two are two acute angles. Okay. But an obtuse triangle has one obtuse angle, a right triangle has one right angle, and the other two are acute in both of those. If they ever ask you to classify a triangle, then they want you to classify both ways, by sides and by angles. So you want to give two answers. You want to give one of the choices from sides, either equilateral, isosceles, or scalene, and then one of your choices from angles, acute, obtuse, or right. Let's try a couple of these after we talk about interior angle measures. The interior angles in a triangle add up to 180 degrees. We may have already known that. We may have already heard that before, but if not, that's something that we do need to make sure that we know for sure when we are working through examples. Okay. Example one, find the missing angle measure. So we're going to go through these and we're going to end up deciding what type of triangles they are based on angles. We can't classify on sides, but we can classify on angles. So let's take a look at this one. Example one, part A. We have two angles. We have 65 and 45 degrees. We want to find that third angle. So we got to take 180 and we're going to subtract 65 and 45 in order to get the measure of angle D. If we take both of those away from 180, we would get 70 degrees. So angle D is 70 degrees, and we would call this, all three angles are acute, so this is an acute triangle. Part B, we have two angle measures. We have 75 and 55, so we want to take both of those away to get angle W. 180 minus 75 minus 55. That would leave 50 degrees for angle W. Again, all three angles are acute, so this is an acute triangle. We can't classify on sides because we don't have side measures. Let's take a look at part C. Angle R is what we're looking for. We have 40 and 30 as our other two angles. So again, we want to subtract away from 180. We know the total would be 180, so we want to take away the other two angles. 180 minus 30 minus 40. 180 minus 70 would leave 110 for angle R. Now, notice on this one, R is 110 degrees. That is an obtuse angle, so this is an obtuse triangle. So we had two acute and one obtuse. Really quick, this is a theorem, but it's not so much memorizing a theorem. It's just important to know when you're working with triangle problems, if you have two angles that are congruent, then the sides opposite those angles are congruent. So this is when we're dealing with an isosceles triangle theorem. So if we know that we have two congruent angles, we also have two congruent sides, and vice versa. Okay, so all of that it probably should be kind of a common sense thing, but in case we've never seen this before, I just want to make sure we know. So taking a look at this triangle here, we have the two sides AB and AC are marked congruent. That's what those dashes mean. And then I've drawn arrows here to show you that the angles opposite those are the ones that are congruent. Angles B and C would be congruent angles. So the measure of angle B and C would be congruent, and side AB and AC would be congruent to each other. Okay. That can be helpful when we're solving for different things in a triangle, especially if we're solving for maybe angle measures and we know we have two congruent sides, then we know we have two congruent angles. All right. Another one that can be very useful when we are solving problems is the exterior angle theorem, which says that the outside angle of a triangle is always equal to the sum of the two far away, so the non-adjacent interior angles. So take a look at this example that I have here. We're saying that the exterior angle, okay, this angle out here, is equal to the sum of the two non-adjacent interior angles. So the ones that are not adjacent, so not right next to it, if we add these two together, angles A and B, we should be able to get this exterior angle. They should be congruent to each other. This can be really useful. If you think about why does this happen? You would add 70 and 60 and take it from 180 to get this angle here, right? Well, this angle down here is linear with this exterior angle, which means they make 180 degrees. So you would be taking this interior angle from 180 to get this exterior angle because they're a linear pair. That's why this works, okay? Because they both have to add up to 180. And again, this can just be really useful when we're trying to solve problems. We'll take a look at what those might look like, okay? Let's start using our different properties to solve some problems. Take a look at this first one. Solve for x. We have 55 degrees, 54 degrees, and x plus 74 as our other angle. So we know that the total has to be 180. So we want to take 55 plus 54 plus x plus 74 and set it equal to 180. Okay, so if we work through this one, we need to go ahead and combine our like terms. So we're going to add 55 plus 54 plus 74. That's going to give us 183. So we have x plus 183 equals 180. Subtract 183 and x has to be -3. Now, this can be confusing for some people. I intentionally put some in here that have a negative answer for the variable. A lot of times people get confused and say, well, how can I have a negative answer for my variable? Here's the thing you want to think about. It's just that your angle cannot be negative. Think about if we plugged x back in. The angle measure is x plus 74, right? So if we do -3 plus 74, that gives us 71. So the angle is still a positive measure. Okay, so you can have a negative answer for your variable as long as your angle measure is still positive. Let's take a look at B. In B, we have 8x plus 2, 70 degrees, and 60 degrees. Again, we know that these need to add up to equal 180. So 70 plus 60 plus 8x plus 2 equals 180. Let's combine our like terms. We have an 8x. Now let's look at the numbers. 70 plus 60 plus 2 is 132. Okay, if we take 180 and we subtract 132, that's going to leave us with 48. So 8x equals 48, divide by 8, and x equals 6. Okay, you can also always plug back in your answer and make sure it makes sense. Take a look at our angle. Our angle is 8x plus 2. So 8 times 6 is 48 plus 2 is 50. If we add all three angles up, a total would be 180. 70 plus 60 plus 50 is 180. So you can always plug it back in and make sure it works. Okay, last one. we have two interior angles, 64 and 27, and then we have the exterior angle, 97 plus x. Now remember what we just said with our exterior angle theorem. We said that the exterior angle is equal to the sum of those two non-adjacent interior angles. So we know that 97 plus x should be equal to 64 plus 27. Okay, let's go ahead and just add these two together. Okay, if we add 64 plus 27, that's going to give us 91. Let's subtract 97, and x is going to be -6. Now again, don't freak out. Check and see if your answer makes sense. Okay, the x is with the 97, 97 plus x. If we do 97 plus -6, that's going to give us 91. That's still a positive angle measure, so that can still work. Okay. All right. Let's try some more. Take a look at this next one. We have two angles that have to do with x. Okay. Notice that this one was just to find the measure of angle A. So not only are we going to have to solve for x, we are then going to have to plug back in and solve for the correct angle measure that they want us to find. So we know that the total should be 180. So let's add x plus 59 plus x plus 51 plus 84 instead of equal to 180. Okay, let's combine our like terms. If we take 59 plus 51 plus 84, that gives us 194. So we have 2x plus 194 equals 180. Then we want to subtract 194. That's going to give us -14. So 2x equals -14. Divide by 2, and x equals -7. Now again, remember, we can have a negative answer. That's fine for the x, as long as the angle measure is still positive. We want to solve for measure of angle A. So let's plug back in. -7 plus 51 gives us 44 degrees. So notice that your angle measures are still positive, even though you got a negative answer for x. Now, take a look here at the next one. This one is involving a couple of things that have to do with a prior unit. Notice that we have an angle on the outside. That's a vertical angle with the third angle in the triangle. So we still may be using some of our vertical angles or linear pair properties in order to solve. Okay, we know those two are equal, so let's plug in. We know that these three angles inside the triangle should add up to equal 180, so let's add those up. 4x plus 17 plus x plus 23 plus 80 should equal 180 total. Let's combine our like terms. 4x plus x gives us 5x. Then we want to add our numbers. 17 plus 23 plus 80 is going to give us 120. So 5x plus 120 equals 180. Subtract 120, so 5x equals 60. Divide by 5, and x equals 12. Now, notice that this one did not ask us to find the value of x. This one asked us to find the measure of angle A. Notice that angle A is listed as x plus 23. So we want to take 12 plus 23, which would give us 35 degrees. Okay, so we're taking it a bit further that time. We're not just solving for a variable. We were plugging back in for both of those. All right, now we're going to find a bunch of different angle measures. We're going to have to put some stuff together. We may be using some angle properties that we know from before, such as linear pairs, or we might be using our triangle properties that we know all three angles add up to 180. So let's take a look at this one and see what we could figure out. We should be able to see that 80, angle A, and 65, that total forms a line, which is 180 degrees. So we could take 180 minus 80 minus 65, and that'll give us the angle that's marked as A. So 180 minus 80 minus 65 gives us 35 for A. Okay, so we found A. Now let's keep going. The next one we could find angle B because we already found A. I'm going to go ahead and label it in here so it's a little bit easier to see. We know that A is 35. So now we have two angles in there. We know that 35, 95, and B should be 180. So let's take those away. 180 minus 35 minus 95 should be angle B. So 180 minus 35 minus 95 leaves 50 for B. Okay. So just in case we need it, I'll go ahead and label it. Notice that this angle, 95 degrees, and C form a linear pair, so they should add up to 180. So let's take 180 minus 95, and that'll give us C, which would be 85. Now notice in this triangle on the right, we have two angle measures. We have 65 and 85. We can take those from 180 to get D, which is our last one we want to solve for. So 180 minus 65 minus 85, and that'll give us D. So let's do that. 180 minus 65 minus 85, and that leaves us with 30 for D. Okay, we did not have any equations in there. We didn't have any variables we were solving for as far as setting up an equation. Basically, we were dealing with our properties of which things add to equal 180, whether because they form a line or because they are a triangle. So knowing your properties are very important, making sure we still know the properties from our prior units. Okay, we're still using linear pairs, and as we saw in an earlier example, we're still using vertical angles, so any of those could show up. All right, let's take a look at one more where we're solving for angles. Notice that in this bottom triangle, we have three angles, and they all have to do with x. Now, notice in the triangle on the right, two of the angles have to do with x, but the third one we're solving for y. So we're going to need to solve for x before we can solve for y. Let's take a look at that triangle on the left. All three angles have to do with x. So we know all three angles should add up to equal 180. So let's set that up. X plus 7 plus 3x minus 18 plus x minus 9 should equal 180. Almost ran out of room there. Okay, so let's combine our like terms. X plus 3x plus x should give us 5x. Okay, then 7 minus 18 minus 9 should equal negative 20. And then we're equal to 180. Now we want to solve for x, so let's add the 20 over. So 5x equals 200. Divide by 5, and x equals 40. Now we need to solve for y. In order to do that, we're going to have to plug the x value in to get those angle measures. Notice this one says x plus 21. Well, 40 plus 21 gives us 61 degrees. X plus 17, 40 plus 17 gives us 57 degrees. So now we can solve for y. We can take these other two away and get the y value. 180 minus 61 minus 57 will give us y. So let's get that. 180 minus 61 minus 57 leaves us with 62 for y. And now we've solved for both variables. The only thing I would caution you about on this one is notice that your answer for y is dependent upon your answer for x being correct. So just you can always plug back in and make sure things work. If you wanted to, you could plug your x value back in for all three angles in the bottom triangle and just make sure that they add up to 180, make sure it works. So that you're confident in your answer, especially for ones like this where one answer is dependent upon the other one being correct. You don't want to lose credit for a question where maybe you could have caught yourself in a mistake, and that way you don't lose credit for both parts. All right, really quick, I have one last thing that I want to go over that has to do with the triangle inequality theorem. Basically, it says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So this should work for all of your side lengths, okay? Notice that the picture drawn here, A plus B should be greater than C. A plus C should be greater than B. B plus C should be greater than A. So any two added together should be greater than the third side in order for it to be a triangle. If, for example, look at these, we're trying to determine whether there's a triangle possible to be drawn given these side lengths, we need to check to see if that works. okay? If any of them do not work, then the triangle is not possible. So let's take a look. Let's start working through A. Is 5 plus 9 greater than 4? Yes. Is 9 plus 4 greater than 5? Yes. Is 5 plus 4 greater than 9? No, it's equal to 9. It's not greater than 9. So guess what? This one is not possible. Okay? As soon as you get to one that doesn't work, you're done. Not possible. Let's try the next one. We have 2, 4, and 8. Is 2 plus 4 greater than 8? No, so this one is also not possible. Okay, let's check the last one. 7 plus 9 greater than 13? Yes. 9 plus 13 greater than 7? Yes. 7 plus 13 greater than 9? Yes. So this is our first one that is possible of these three examples. Okay. Anytime you see it, this is the most you might see. There also sometimes they may give you a range of values, like they'll say what is the range of possible values for a side length. So the big thing to remember is that any two added together have to be greater than the third. Okay. So again, make sure you can plug into these inequalities, make sure they work. And notice on part B, the first one we wrote did not work, so we didn't have to look at any more. As soon as you see one that doesn't work, the triangle is not possible. Okay. All right, guys, I hope this has been helpful and informative. We're going to do a lot of practice with triangles. Triangles are going to be really big for the next several weeks, so make sure you're good with this.